Casual music listeners may not notice if the drums sound a little off or if the synths are kind of squashed, but anyone can immediately tell when the vocals sound wrong. And that's what makes them the most difficult, but arguably the most rewarding thing to mix. So let's cover concepts, techniques, and tips about vocal compression that'll save you years of trial and error. If you're new to Sage Audio, we've been providing industry-leading audio engineering services and education for over 2 decades now, and are here to help you make your mixes sound like professional songs. So let's start with what you might not know about compression. So compression is really where you achieve a vocal's distinctive timbre, maybe even more so than saturation, and here's why. We're all familiar with attack and release, how long before compression begins, and how long compression lasts once the threshold is crossed. But there's a lot more happening than what this simplified definition would have you believe. Now, it's easier to show with some graphics. So say the horizontal line is the threshold, and the vertical line is our attack time, let's say 20 milliseconds. Now, if this vocal is above the threshold, it's not as if our compressor simply waits 20 milliseconds and then causes instant maximum attenuation to occur. Instead, imagine that once the signal crosses the threshold, there's a timer in place set to 20 milliseconds, and by 20 milliseconds, the compressor reaches the maximum amount that it's going to attenuate. So the attack time is not telling the compressor to wait. As soon as the vocal crosses the threshold, it's being attenuated, but only after 20 milliseconds will the maximum amount of attenuation occur. Now, something very similar occurs for the release. Let's say it's 250 milliseconds. Again, it's not as if compression occurs for 250 milliseconds, but stops when the signal falls below the threshold. Falling below the threshold initiates the release, and it takes 250 milliseconds before the signal goes back to its uncompressed state. Now, this means that even after falling below the threshold, the signal is still being compressed. This is even more interesting when we consider how different compressors have different behaviors. In our 20 millisecond attack example, maybe the maximum amount of attenuation is always occurring at 20 milliseconds, but how it gets to that max attenuation can vary. If the attenuation over the 20 milliseconds was linear, and say 10 dB was the max amount of attenuation, then at 10 milliseconds the compressor will have attenuated the signal by 5 dB. But if the attenuation over time is not linear, which is, I believe, always the case, then at 10 milliseconds, we could have 3 dB of attenuation, or maybe 9 dB of attenuation. The same goes for the release. The 250 millisecond release might be linear, but it definitely doesn't have to be, and will vary from compressor type to compressor type. Just to demonstrate this, here's Plugin Doctor showing the effect. It's feeding a sine wave into the compressor and then amplifying it before returning it to its original amplitude. Now notice how varying the attack time makes it easier to observe the gradual amplitude adjustment that we just discussed. Also, notice that even after the signal falls below the threshold, attenuation occurs, which can also be affected by varying the release time. Lastly, notice how the attack and release change behavior when we alter the compressor emulation. And this is really just the beginning of how a compressor alters the timbre. We have harmonics and intermodulation distortion, the general reshaping of the vocal's ADSR, the reduction of masking to quieter details via makeup gain, and a lot more. So with that said, let's get to the key elements for upfront vocals. Now, the current trend for vocal production is to place them right in the front of the mix while still retaining detail and nuance. Compression with these 5 elements are going to achieve this. First, you got soft knee, then it's 4:1 ratio, a quick attack with 1 to 4 milliseconds of look ahead, 5 to 8 dB of attenuation, and then makeup gain. Now, if you use these settings, I can guarantee you'll achieve an upfront sound. First, the soft knee combined with a 4:1 ratio causes more compression to lower amplitude signals, but it keeps the compression sounding natural and relatively transparent. Look ahead with a quick attack causes the attenuation to occur right at the beginning of the vocal by letting the compressor measure the signal before it begins to process. 5 to 8 dB of attenuation is all you need to control even aggressive peaks. But when combined with the previously mentioned settings, it still avoids a noticeably compressed sound. Lastly, makeup gain, ideally automatic makeup gain, brings all of the quieter details forward. Since we smoothly compress, and the compressed signal includes even the initial transients of the vocal, post-compression amplification will bring a great deal of quieter details right to the forefront. So let's take a listen and notice how the vocal becomes detailed and complex, and it sits right in the front of the mix.
Don't waste my time. You talk in circles, say the same thing twice, and how you word it wouldn't change my mind. I'm sleepwalking away. awake, been vacant for days, that's right.
I've tried countless options to improve my mixes over the years, and they always fell short. So that's why we created the Sage Audio membership. It's the only platform that actually delivers results, and it's an incredible experience. But more on that at the end of the video. Next, let's answer the question, EQ before or after vocal compression? Now, this is a common question, but it's kind of a false dichotomy. In other words, we don't need to pick one or the other when both are an option. Use EQ before compression to attenuate any problematic frequencies or anything that you don't want amplified. This might be plosives, aggressive sibilants, nasally tones, unpleasant resonances, unneeded low mids, and so on. Basically, use this EQ to create a balanced and somewhat safe sound. Then, compress and use settings from the last chapter to amplify what's still there, which should now be everything about the vocal that you like and you want to keep. With these elements amplified by the compressor, use a second EQ to amplify everything that you want more of. You could boost some of 2 to 5 kilohertz to increase clarity and intelligibility. You could also amplify some air frequencies with EQ or an exciter. And if you place this EQ later on in the chain, maybe after reverb, delay, and whatnot, you can even amplify aspects of the side image, like the warm reflections around 300 Hz. So don't limit yourself to the so-called right option when you have the freedom to explore different possibilities. Let's take a listen with the compressor settings from before, but now with EQ before and after compression.
Don't waste my time. You talk in circles, say the same thing twice, and how you word it wouldn't change my mind. I'm sleepwalking awake, been vacant for days, that's right.
Last up, let's talk about what to do when compressing vocals isn't working. So let's say you've compressed the vocals, but even then, they still sound weak, far back, or kind of lifeless in the context of the mix. First off, don't compress more. That's a mistake I used to make. More compression, even serial compression, will likely change the vocal's timbre in unpleasant ways. Instead of controlling the dynamics from the top down, let's use wave shaping to control them from the bottom up. Now, wave shaping is commonly used for synths, but if it's used conservatively, you can think of it as a complementary tool for compressing vocals or other instruments. Melda Audio makes a great free wave shaper. With it, I'll amplify quieter details, similar to how I did earlier with the compressor's makeup gain, but this time, I don't need to attenuate peaks. If I only want the quietest parts to be amplified, I could double-click to create another point, drag it to the desired amplitude range, and then drag it upward to amplify that range. Meanwhile, I'll ensure that I have a linear or one-to-one input-to-output relationship for everything above the affected amplitude range. This way, details are brought up, while the peaks stay the same level, causing upfront vocals without messing up its timbre. Let's take a listen to two wave shapers, this Melda Audio one that I just talked about, and the popular Oxford Inflator. Now, Melda Audios will probably give you more flexibility, but the Inflator has a great sound nonetheless.
Don't waste my time. You talk in circles, say the same thing twice, and how you word it wouldn't change my mind. I'm sleepwalking awake, been vacant for days, that's right.
As I mentioned earlier, I've tried countless options to improve my mixes over the years, and they always fell short. So that's why we created the Sage Audio membership. It's the only platform that actually delivers results, and it's an incredible experience. The membership includes unlimited mixing feedback, direct one-on-one mentorship, in-depth mixing and mastering courses, 50 free mastered songs per year, and a lot more. Every day, I see huge wins for members noticing a massive improvement in their mixes after joining. Use the link in the description to see if the Sage Audio membership is right for you.